This is the second video for section 2.5 where we do some chain rule examples. So let's suppose that in this video we're going to suppose f of x is sine x and g of x is the square root of x. So remember f of g of x, we take f, we evaluate it at g of x, so f of g of x is sine of the square root of x. So if we want to take the derivative of this function, we need to first of all recognize that it is the composition of two functions, and we're going to use the chain rule. So we're going to take f prime evaluated at g of x times g prime of x. And if we do that, the derivative of sine is cosine. So we have cosine evaluated at square root of x times the derivative of square root of x, which is 1/2 x to the negative 1/2. So that's the way the chain rule works. Let's see a few more examples. Before we go on, just notice that the cosine, that's the derivative of the outside evaluated at the inside times the derivative of the inside. So that's the way the chain rule works. Or if we wanted to use the alternative version of the chain rule, we could let y equal f of u, which is sine u, where u equals g of x is the square root of x. So if we do this version, remember we have dy dx is dy du times du dx. So dy du is cosine u times du dx is 1/2 x to the negative 1/2, but I want to write this all in terms of x, so I use my substitution. I use the fact that u equals the square root of x, and I get cosine square root of x times 1/2 x to the negative 1/2. So another way to sort of think about the chain rule and use it to compute the derivative of f of g of x. Okay, so now let's find the derivative of g of f of x, and I recommend trying that, pausing the video and coming back and seeing how you did. So g of f of x is the square root of the sine of x, which of course we can write as sine x to the 1/2. So the derivative of g of f of x is going to be now g prime of f of x times f prime of x, because the role of who's inside and who's outside has switched this time. So just, really be thinking about how the chain rule works. So I have the derivative of the outside evaluated at the inside here. So that's 1/2 sine x to the negative 1/2. So the derivative of the outside is sort of the x to the 1/2 power. So I use the power rule to bring that 1/2 down and subtract 1 from the power, but I'm evaluating it at the inside, excuse me, which is sine of x, and then times the derivative of the inside, which is cosine of x. And again, let's see it using the alternate version of the chain rule. I let y equal g of u be the square root of u, and u equal f of x be sine of x. So then g of f of x is y. So dy dx is dy du times du dx. dy du is 1/2 u to the negative 1/2, and du dx is cosine x. But now I don't want to have u's and x's, I want to have just x's as my variable. So I substitute in the fact that u is sine x. So I get 1/2 sine x to the negative 1/2 times cosine of x. So let's, just to make things a little bit more complicated, let's add a third function to the mix. Let's let h of x be x squared plus 1. Now, f of g of h of x is sine of the square root of x squared plus 1. So I want you to see if you can use the chain rule for 3 functions to take the derivative of this guy. And remember, the chain rule for f of g of h of x, the derivative of that is f prime evaluated at g of h of x times g prime evaluated at h of x times h prime of x. So take a minute, see if you can do that. So that first piece, derivative of the far outside, derivative of sine, is cosine evaluated at g of h of x, which is square root of x squared plus 1 times g prime evaluated at h of x, so 1/2 x squared plus 1 to the negative 1/2, times the derivative of h, which is 2x. So I can just sort of, as long as I start from the outside and leave the insides alone, I can actually differentiate as many function compositions as I want to. And believe me, we will get practice doing that in class.